Thank you very much for inviting me, and it's a very lovely space to host user group meetings. Thanks, Paul, and all the sponsors to have all the setup and making things happening. So tonight I'll have two talks. This talk is a talk which I and my co-author from my JavaEE book, Alex, prepared together. We were planning to submit this to JavaOne, which doesn't exist anymore. I think it's Oracle Code 1 now. We missed the call for papers, so probably we'll send it to Devoxx. Then I'll have the JavaEE design patterns talk, which I did several years ago, but I updated the slides mostly. So one thing to note, accept my apologies for going through a lengthy, painful dental thing. So sometimes not all the sounds come as I expected, but we'll make it. Why my clicker is not working. Okay. So I think we talked enough about me. I'm a Java champion in XGD, which is a equivalent of Java champion in terms of Google, which is super funny because they kicked me out of the program the day I joined Google. So that's why I have the X. Actually, the team who kicked me out, my wife was part of that team. So I happen to wrote 2 books in the past. I'm working on a new Kotlin book, shameless plug to the Kotlin user group, so I can come back to beautiful San Diego again. And if you want to reach me, this is my Twitter handle. If you put the at the end and at google.com, that's my email. Then I guess we can move to the talk. Let me adjust my screen here. So this talk, I'll be talking about the new JSON Processing API and cover the additions to this API. I will first talk about JSON binding, then dive into how to use the new API, and I'll finish with a roundup and then give you some time to ask questions before the next talk. And if you see me drinking water all the time, it's again because of the dental stuff. Sorry for that. Hopefully it will be soon coming to an end. So let's first start with the JSON Processing API 1.1. Let's start with a quick reminder of the 2 models for processing JSON, the object model and the streaming model. So both the streaming and the object model can generate JSON data and output a stream, such as a flat file for offline processing and storage. So the JSON-P object model is a memory-based model which loads the entire JSON document into the memory. And as it loaded, it's parsed into a JSON object structure with JSON value class at the top. The model consists of a JSON object, which represents a JSON object, obviously, and the JSON array represents the JSON array and all other values such as string, number, represented JSON value. The object model reads JSON data from a file, stream, or just a string, parses it into a JSON object, which into a JSON object instance, and actually can also parse directly to a JSON value or a JSON string. The JSON object contains the structure of the JSON document and can be queried by using a selection of methods that retrieve data from the model. The code snippet here basically shows that methods. The get method retrieve a JSON value from the model, and get JSON array retrieves the whole array given a key, and get boolean will return true or false. The object model can write out JSON data from a JSON object instance to a file, stream, or a string, as in the code snippet. So here we are creating a alt JSON and then writing our JSON object into that. This code writes the value of the JSON object instance generated from the previous example, and we just create a new file containing the data. The streaming model reads JSON data one element at a time and fires an event each time it reaches one of the following element types. So it can be the start or end of an object, the start and end of an array, a key name, and in a string, number, boolean, or a null value. The parser stops at each event, and it can either process the element or discard it. It moves on to the next event until all elements in the JSON data stream have been parsed. By the way, this is very efficient. It uses a low-level API designed for parsing large quantities of JSON data. And the API consists of two principal interfaces, JsonParser and JsonGenerator. Both interfaces come from JavaX JSON stream package. The JsonParser interface provides read-only access to the JSON data it parses, and it traverses in the forward direction only. The next element, which we use over the parser, the next element in the JSON document is pulled by calling the next method. So it continues iterating over the data until the data is exhausted. This code snippet just loads the JSON document into the parser, iterates over by using the next method I mentioned. So the JSON generator interface. This interface provides a collection of methods that write JSON to a string. It's written as JSON array and name value pairs in JSON objects. To write the JSON data using the streaming API, you need to obtain an instance of the JSON generator by calling the static factory method from the JSON class, and then passing it an instance of either a writer or an output stream, which, as the code snippet suggests, and then by calling the builder methods, the JSON object structure can be built up piece by piece. When you're finished, you need to call the close method to indicate the object creation is completed. Oops. And of course, if you're writing to a file, you need to call flush and close. Right, so let's move on. What's next? What's new in the JSON Processing API? This release is a point release, which actually brings JSON-P up to date with latest IEFT standards, which are JSON pointer, JSON patch, and JSON merge patch. A JSON pointer basically defines a string expression that references an element within the hierarchical structure of JSON document. If you're familiar with the X pointer and the way it identifies elements within an XML document, JSON pointer works much or less very similar. With the JSON pointer expression, you can JSON pointer expression, you can access and manipulate the JSON document by retrieving, adding, removing, or replacing an element or value or value referenced by the expression. The entry API is the JSON pointer interface, which you can instantiate by calling the static factory method create pointer again from the JSON class. Given a simple JSON document consisting a title, if you want to retrieve the value of the title key, the expression you create will be /title. So all non-empty JSON pointer expressions must begin with a slash followed by the path of the key. This code snippet creates a JSON pointer and references the title element. Then calls the getValue method, and which is passed the JSON object to query. The result will be a JSON value that represents the value of the title element. Next, let's see JSON pointer retrieving value. A key and value is referenced with the key name or array index. So to retrieve a value, such as length in this case, in the first element of a array called other books, we need to build an expression like /otherbooks/0, which is the index, /length. And the code snippet here will retrieve the value of 350 by calling the path. To add or insert a value to a JSON document, we'll follow a similar logic. A JSON pointer expression identifies the insertion point within the document. The value to insert must be a JSON value type, which you can create using one of the builder methods of the JSON class. Again, the code snippet adds ratings to JSON object to the root of the JSON document and referenced with the key ratings. So as you might guess, our code will, oops. Oh, it's brutally hard to find this on a blank slide. We'll add the start and score just after the ratings. And just after the title with the key ratings. So this will be super easy by using the pointer syntax, which is again all new and released with the new JSONP. The removal requires the location of the value to remove. The code snippet here removes the title element and returns the modified JSON document as a JSON structure instance. So again, we are finding the title and removing the JSON object, JSON part related to the title. As a result, we end up with the ratings. To replace a value, the JSON pointer expression of the element to replace and the replacement element is passed to the replace method. The code snippet here replaces the title element's value and returns the modified JSON, which you can see at the bottom of the screen. So basically, the pointer just points the title. The second parameter we pass to the replace method will replace the original object. The existence of a value at a location can be tested by contains value method. In this code part, we basically test to see if there's a value at the location expressed by the JSON pointer expression. So this code will check if the title contains the value, if there's a title value, and then if there are any chain calls, it will continue running the remaining. JSON patch, which is also part of the new API, expresses a sequence of operations to apply against a target JSON document. The operations are formatted in JSON pointer notation and can perform add, copy, move, remove, replace, and test. The JSON patch builder interface is the gateway into this API, and again, it's created by calling the static method create patch builder from the JSON class. JSON pointer, JSON pointer expression is passed to one of the operation methods and applied to the JSON document. Next, let me get my pointer here. The replace operation is performed by replace method, obviously, and by passing it the location of the element to replace, expressed as a JSON pointer expression, and the replacement value. So in this case, we are looking for chapters, the first index of the chapters array, and we are looking to replace it with a new title. The resulting JSON document will be something like this. Next, add and remove. A key feature of JSON patch is the capability to chain multiple operations, as I kind of mentioned previously, and sequentially to the result of the previous patch result. If an exception occurs during one of the operations, basically the operation stops and no changes are made to the original JSON. So in this code, we first call the add method to add a new chapter, and then remove released, and then build our JSON file. If any failure happens during calling add or remove, we will be receiving back the original document. However, this way, in this example, we will just succeed and create a new JSON file containing the new chapter, and as you can see, the released part will be removed. Move and copy. The move operation requires two JSON pointer expressions, and basically it moves one element to the new location. The target location must already exist and follows the same logic as the add operation, in the sense of that it displaces the element at the specified location with the element to move. All elements are effectively shifted one position. The copy operation, replaces an element's value with the value of another element. So this operation also requires two JSON pointer expressions, one for the source and the other for the target's location. Both of those, the order of the method parameters is important, and the destination element's JSON pointer location appears first in the parameter list. So the code here chains three operations together, two move and one copy. Again, a failure to perform one of the operations will just create an exception and will not change the original JSON document. But in this case, we will move two elements and we'll perform two move operations and do a copy. And do we have the? Okay, and let me rewind back. And we will change the JSON file and display it on the top. Next, patch test. The test operation determines if the specified value is set in the JSON document. If the test fails, the patch operation stops. And otherwise, it goes ahead and completes the remaining operations. As you can see, the API works consistently like this. So if one operation in the chain fails, it stops there. The code snippet here, the element pages is tested. So we check if the element pages exist, which it does. Then we do a copy, and if the test operation failed, which would mean the pages is not there, the execution will stop and no copy will be done at that level. And at the end, we will end up with the JSON like shown in the below the code. Next, JSON merge patch. Merge patch is a JSON document that describes a set of changes to be made to form the target JSON document. So this table here basically shows all the operations available in JSON merge patch. Can performs replace, add, or remove to match the final JSON. Again, to use merge patch, we call the static create merge patch method on JSON class, and then we pass the parameters in the order. So the apply method will result in a JSON merge patch, and instances pass the target JSON and the patch is applied. This code will show how to perform and the replace operation from the table. Merge diff operation generates a JSON merge patch from a source and target JSON value, which then, when applied to the source, will result in the target. So basically, it creates the diff, which will create the final JSON target. Let's talk a bit about JavaEE integration. So using JSON with JavaEE streams has become much simpler with the introduction of JSON collectors class, which is under JavaX JSON streams package. So in the code snippet here, the text array will be filtered by J, the character J, and the result will be collected into the JSON array, which is like super nice. Now let's move to the new JSON Binding API. Any questions so far? Good question. I don't think so. I think it should be a dependency, but I need to check that. Remind me that after the talk and let me. Let me check that after the talk. So yeah, next JSON Binding API. So the Java API for JSON binding, which is JSONB for short, strengthen the JavaEE platform's overall support for JSON data interchange format. Already the Java API for JSON processing, which is JSONP, has been really popular. And together with JSONB, they form a better partnership, and it's much easier to do stuff. The JSONB specification codifies industry practices and methodologies that have become commonplace. If you are familiar with JSON on any platform or with any library, you should find it very, very similar, which was the main design point after behind JSONB. So out of the box, it provides default mappings for serialization and deserialization, which most of the time handles the job. If you need default customizations, there are ways to do it. So let's first talk about the default customization methods. So the first one is compile time annotations, which is super easy to use. You just annotate the parts and get the result. And the second one is runtime configuration builder, which again should be doing the job on most cases. However, for advanced customizations, the API provides adapters, serializers, deserializers, especially for the times when you're dealing with third-party dependencies where you cannot change the code and add your annotations. The primary feature of this API is the provision of binding support between Java classes and JSON documents in an easy to use manner so that a developer with no prior JSON experience can still use it easily. And for those who has JSON and other JSON library experiences, like JSON or JSON, it will feel very familiar. That was the purpose. So the JSONP API provides two entry point interfaces, JSONB and JSONB Builder. The JSONB interface provides the serialization and deserialization functionality via methods like toJSON and fromJSON. And the JSONB Builder interface provides the client and access point to JSONB instances. It basically builds the instance based on a set of optional configurations. Let's jump in with a simple example that does the round trip conversation of an instance of a book class. To start a serialization, or deserialization, you need to have an instance of JSONB. So we get the JSONB instance first. You create this by calling the static factory create on the JSON builder interface. With this instance, you can perform all the serialization and deserialization operations you require by selecting the appropriate overloaded to JSON or from JSON method. In this case, I'm calling the toJSON method, which is the simplest to JSON overloaded to JSON method, which receives a Java object and serializes it into a string. And similarly, from JSON, we'll receive a string JSON. And again, this is like the simplest from JSON implementation. This one will receive a string and the class type, and we'll create the Java object from the JSON. So for simple scenarios and for most common cases, the default mapping behavior is mostly sufficient. However, the more complex scenarios, there are several ways to customize the behavior to your needs. I'll introduce them a bit later in the talk. So first, there are two customization models that are used together or separately. So one is the annotation model, which basically you can annotate your fields or classes. And the other one is the runtime model. Let's see more info about that. First, let's see the annotation model and the runtime configurations work. Using the annotation model, you can basically customize the default serialization and deserialization by annotating fields, methods, or classes. For example, in this code, we're using the JSONB nullable annotation to customize the null handling and the JSONB property order annotation to customize the property order. And these two annotations are specified at the class level. Similarly, we have annotations on the field level, which does change the name of the property and specify a number format for the property. And alternatively, you can choose to handle customization with runtime configuration builder by configuration an instance of JSONB config and passing it to the create method of the JSONB builder, such as in this code. So again, we set our properties by calling the method chain and create our JSONB config, then pass this to the JSON builder. So let's take a look at how JSONB handles custom object creation. So let me see how I'm on time. Okay. So JSONB expects all classes to have a public no argument constructor, which it uses during deserialization to instantiate the target class. So once the instance is created, it's populated with data by calling the appropriate setter methods. Or if it's a public field, can be accessed directly. However, sometimes this is not sufficient, especially when construction is complex and for these cases, a custom constructor or a static factory method must be implemented. For example, in this code here, we use a custom constructor where we map the values by using the JSONB property. So this JSON document is successfully deserialized as a magazine, and basically we'll create the from this JSON file to Java, we will create the mapping. What about JSON binding with adapters? So let's talk about custom object creation with JSONB adapter. Basically, an adapter configures a custom object creation and serialization by implementing the JSONB adapter interface. The methods you need to implement are adapt to JSON and adapt from JSON. So basically, you need to override the logic and perform the serialization and the serialization binary rules you define. For example, in this code, the adapt to JSON method is implemented with the code which transforms the booklet into a JSON object using the JSON object builder from the processing API. And similarly, adapt from JSON constructs the booklet object from a JSON object instance. You can see the adapt to JSON method flattens the outer object to two properties, first name and last name. And adapt from JSON method reconstructs the outer object and outputs the booklet instance. The JSONB adapter is very flexible and can be used to customize any custom behavior in the serialization and deserialization of the fields. This is achieved by marking the field, method, class, or class that should be customized with the JSONB type adapter annotation, and passing it the class name of the JSONB adapter to use. The example implementation here, the first name field marked with the JSONB type adapter, and the first name adapter class specified as the adapter. So for this field, JSONB processing will use the adapter provide for the field. And finally, the most advanced way to customize your serialization and deserialization by using custom serializers and deserializers. JSONB serializers and deserializers are the lowest level of customization available in the library, and they give you access to the JSON processing parsers and generators. A custom serializer must implement the JSONB serializer interface and provide the logic for the serialize method. So this example, we create a custom serializer for a book object. The JSON generator is used to create JSON document property by property. The value of the ID property is fixed, and the outer name is again created by dividing the outer's name into two pieces. And for the deserialization, again, the operation can be customized by overriding the deserialize method from the JSONB deserializer interface. Here in this code, we basically extract the book ID from the JSON document and only use this part for deserialization. Instances of the serializer and serializer can be registered by a JSON config via appropriate with deserializers and with serializers calls. And alternatively, the type can be annotated and by using the JSONB type serializer and JSONB type deserializer annotations. So basically, we have seen the new exciting features for JSON processing with JavaEE. To wrap up, JSON processing is now up to date with the latest standards by IEFT, if I remember right. And the JSONB designers have set out to standardize the way developers interact with Java with JSON. So you may have already realized it's basically much or less the same way JSON or JSON interacts with JSON. If the API and features you have seen so far is not that familiar, you can still jump in and use it easily because, again, most of the current JSON processing libraries and APIs work much or less the same way. So most of the examples you will find will much or less match the new APIs. And the two customization models, runtime and compile time, offer a highly flexible way to fine-tune the API. And you can always write your own serializers and deserializers using the low-level manipulation and achieve the custom serialization goals. So I think that wraps up my first talk. I'll check the dependency for the JSON P API. And if you have any other questions before the second talk and the break, I'll be happy to answer.
Thank you.